Welcome to this 21st session of Ergonomics for Beginners Industrial Design Perspective. Today we are going to discuss today's current module number 4, that is posture and movement. Out of 8 classes within this, today is the last but one class, that is that today's session is class number 21, that is movement and its performance relevance. Now, the gist of last class whatever we have discussed, that is the workstation layout, where we mentioned that for a standing person or a seated person, the primary work area, that is a horizontal space in front with the palm akimbo length and the palm depth and the forearm depth. This much space is the primary work zone, and this primary work zone can be extended with the span, total span, and the frontal one forearm depth, and then with total arm extend with a full arm, the total area is covered, that is the secondary work zone, and with bending front, side and back, it would be the tertiary work zone. For standing person with one step, the total reach values, that arm arc is the maximum work reach zone, and out of that is the out of reach. So, according to various importance, like the functional layout of components in respect of user's position and functional ability, based on 4 principles of component layout, as the principle of importance, principle of frequency of use, principle of functional priority, and sequence of use principle. With that, the work component should be placed within the specific work zone areas. Now, the physical aspect of users comprise the body itself, where we need to concern that its structure, growth and function, differences in various adopted postures, like to minimize biomechanical stress, to allow easy reach of limits, to allow the ability to shift posture. Means, if a person performs a task for a quite longer time in a single posture, it would be tiring. So, it is advisable that one person should try to shift their postures, various postures, maybe from the workstation should have the facility for adopting sitting, standing and some other postures that suits to that task. Now, another thing is that the limitations of ranges of movement of body parts and biomechanics are necessary to consider when a design dimension decision is made. Now, this particular area we are going to stress today. So, with this, the today's topic, the class number 21 is that movement of human body according to task and performance relevance. So, movement, the dynamism of body parts, either parts of the body or body as a whole, and the task and space around. So, our today's discussion will be within these limits. Now, the first point we can say that the being stationed at a point and stretching out means the person being stationed, the person is not moving, the being stationed when is stretched out to do certain task, then what concerns we should consider. Now, in this class we are not going to give any design solution or any specifications. Here we are raising some concerns and issues that we need to consider while making any design attempt. Basically, based on the human body structure, behavior and movement ranges. Now, in this case, what would be the design requirement? Whether we need to provide any specific support system here, or we should do certain design thing so that this latch can come down for her requirement. This type of studies we may do. Now, next concern we can say that movement with central focus remained unaltered. Means, when we do certain work with the frontal attention while doing, then if it is necessary to work upon some other areas, so that if we move shift to that position, how fast we can come back to that original work area. So, that facility how we are giving, that facility needs to be provided, so that whatever the task we are performing, accessories we are handling, but our main focus is to work on the central focus area. So, that should not be unaltered. Now, another thing is that horizontal work area, front, side and backward movement. Now, which one is better? Which one would be comfortable for us? So, accordingly the work area or work surface should be placed. Like it is said that frontal work area is always better. Sideways we can have, but backward it is better to avoid if the body movement facility is not provided. So, in that case, the location of the person means that how with minimum effort that body can move to touch all those points we need to consider. Now, the placement of this thing. Now, normally what is happening for our body axis, the central body axis, now our arm is placed in such a way that if we try to exert if you want to do some task handling some lever, if it is towards the central of the body line, then it is little difficult to operate. While operating, we need to provide a space so that this elbow can freely move. Now, then the backrest and its backrest has to be considered accordingly, so that there should not be any hit, any obstruction of the elbow movement. It is better if we can keep a handle or a switch or a gear placed from the central body axis at around 30 to 45 degree angle, this range, it will be easier to move, so that this elbow instead of going away from the main body, it will be closer to body. So, this type of movement is always better. So, these considerations we need to consider when doing some design activities. Now, just now we said that the sit and stand movement Now, if a work area requires only sitting, then some provision should be made so that the person can get chance to stand or they can get some chance to change the position, so that the working in a constant sitting position should not be fatigued. Now, another thing that squat and other postures. There are many activities in squatting and etc. So, now for the squatting, earlier classes also we mentioned that some body supportive devices should be provided, and also some freeness of movement, means the situation should be made in such a way that a person can choose his posture and can perform the task. Then circulation in and around the space. Circulation, what happens? When a person moves, earlier we said that a person has a specific volume in a space. Now, when he moves to somewhere, that space also moves accordingly, and if he takes any posture bend or some other changes, then that volume also takes the same shape. Now, when he moves, so whether it will be a straight 90-degree angle movement or there should be a little circular end movement, that is necessary to be considered, because man, as per his normal behavior, it is man does not move in a straight right angle way, or he does not walk in a straight line. So, there will be always sway movement like that we will see now. So, all these things we need to consider, and the space around, there is also that not only the physical space to work upon, but also the psychological space feeling, that is territory feeling, should be considered. Now, here if we see that not only in the working area, but in leisure time also the same aspect we need to consider. Suppose this is the house, the drawing room design. In this drawing room, that how many persons we are expecting, how many visitors we are expecting, and what type of interactions they will have, all these things we need to consider, and accordingly the ease of going in and coming out from this space we need to think of it accordingly, and then the reach values and etcetera, it has to be considered. And then obviously, the furniture dimensions are there. Now, mostly while making footpath or some special space, we think or we feel to move around or go, then what would be the total space that needs to be considered, and then the clearances. Now, whether only walking or walking with some equipment or object in hand, or walking with an aid, that is maybe some vehicle type of thing, whether those things are necessary, that is to be considered. Suppose this is in this figure, it is shown a historical place, and this historical place, all the archaeological material are inside and it is fenced. Now, it is supposed to move around the fence and see the articles, but now the young men or normal common adult people, they can move by walking, but if there is a old person comes or any tourist or visitor who is not able to walk, and for them wheelchair or some kind of mechanized moving item should be used, then that facility whether is possible or not, that should be considered, including the bending here and etcetera, what would be the arc we need to consider in this case. Now, for any space that where we need to cross over, suppose the tall people, short people and like this, and the people are supposed to carry something, all these things we need to consider. Whether the things he is carrying, what type of material is one is expected to carry, whether and the carrying mode, whether on the head or hand or something, that we need to consider. The office area. In this office area, the circulation is that this is the single workstation area where the table and the work material, chairs are there, chair for the occupant and the visitors are there. So, what would be the total movement pattern here, and accordingly the space we need to consider. So, then how many people are supposed to cross in this lanes? What would be the frequency and what is the timing for that? That need to be thought of here. Not only circulation, the persons are also supposed to do this type of activities, means the work also. Then when a person moves through this lane, then only his body dimensions, that is standing depth, breadth are considered and then walking area is considered. But while performing certain tasks, which some people also need to do this, then what would be the special allowance is required, that needs to be considered, and then whether supervisor needs to observe the whole area, then what type of furniture facility is required, that we need to think. Now, another area is that here the people are confined, as they are attending one conference. In this conference, unless the delivery of the speaker is over, these people cannot come out. So, if this facility is provided that they may come out, then the space in between needs to be considered. What would be the consideration? The total seat depth and around the same space we require to keep free in between two rows of the bench and the chair, so that one can come out without disturbing the whole group. Similar thing also can be considered in this community feast. Unless if someone wishes to come out, unless the other people they finish, it is difficult to move out. So, then what will be the gap in between, this needs to be think. So, accordingly the space arrangement has to be developed. So, this we can say that circulation clearance is necessary and single person and multiple persons use. Now, single person, if we see here that a single person is walking. Now, we can say that whatever the total distance with the relaxed position from the total body breadth needs to be considered. So, accordingly if we make a path, then it may not be comfortable, because while walking the man cannot walk in a straight line. So, there will be sway. So, that sway we have to, that clearance we have to give, otherwise it will be psychologically troublesome. Now, if that two persons are supposed to cross side by side, then we can say that take the whole depth. Suppose if this is the one unit, if this total depth in distance is 1 unit, then we can say that this will be 1 plus 0.75. Why? Now, because if the two persons walk side by side, then there will be some squeezing. If 3 persons work side by side, then we do not require 3 times of this. There we require maximum 2.5 of the total. If it is 1, then 2.5. Why? Because 3 persons, if they move together, they will not move at the same line. They will be either one is front, back, like that the arrangement will be there. Now, this we will try to see in this case. Now, when the 3 persons are moving together, they will never walk in a straight line like this. There will be some front back arrangement of walking. So, accordingly, that is the considerations. Now, if we see this, then now we will see some of one movie. Here we will see that how it moves. Now, see the single person's movement. Now, when she is moving, she is not following a straight line, the sway movement is there. So, this sway movement we need to consider. Now, another thing is that when male and female both walk, the female body size they move at the hip. So, hip it is moving like this way, but whereas when a man moves, there the hip remains static, but their movement is shoulder movement will be more. Now, with that it is seen that the ladies who have little heavy buttock, for them the sway movement is more, and then so the straight to go in straight line is little difficult. So, for them the moving from the left and right side covering like this way from the central axis of movement is there. Now, if we see this figure here, this movie, this clip, in this clip it will be, now we can see that one man and his wife both are walking on a corridor. Now, see the movement pattern, the man moves, the hip is not moving much, but the shoulder is moving, whereas when the lady moves, the shoulder remains relatively static than the buttock movement. So, when the buttock movement is there, so the more sway movement is also there. So, while walking or while designing some walking area or pathway, all these aspects we need to consider. Now, the next step we can say that the movement and attention to some object. Suppose the person moves, the thing I want to see that remains static, then that one consideration will be there. Another consideration is that the person is static, but the object is moving. Another is that person is moving and object is moving at the same direction, either with the same speed or different speed. Then the visual interaction with among these two. Another is that the person is moving in one direction, but object is moving opposite direction with varied speed. Then what would be the perception of those items to be seen? So, in that case it would be like this. So, now we will see the 3 specific factors like that: movement and attention to some object, person movement and object movement, person's position static and object moves or vice versa. Now, here this is a conveyor belt in an airport where the luggage is coming. So, person is standing and this luggage, this conveyor belt height is almost at the knee height, means roughly it can be said that as per your normal sitting height. Now, while taking out this luggage, so the luggage is coming from this side. So, they are all looking at the coming in position, then they have to collect it and then transfer to the trolley. Now, while transferring this thing, so the person has to lift this load in an awkward posture and then shift it. So, there is a design scope whether that lift that or that trolley can come very close to this and just only pulling it can be shifted. So, then it will be less tiring or less problem in this posture area. So, this is one type of task concerning movement. Another thing is that the person moves and the object of that is a work equipment also moves. He does not need to push with that there is some here he is pushing, but in some cases where the electrical power is given here. So, that the work equipment moves and the person also moves, he has to control like that way. So, in that type of one movement, then in this case we require to maintain the pace between this equipment and the person, not the surroundings. But when they are moving and they are taking a turn, then what would be the angle in this case, that needs to be considered. So, that the person's comfort is a concern here. Now, another thing is that design for whole body movement means whole body is moving on an object. Now, what would be the design considerations? There are varieties of considerations are there, but one thing I would like to say here that dimensions according to body movement requirements means this is a seat suppose. This person has to sit on it, means it is a body supportive structure. Now, this body supportive structure and the seat type of body supportive structure is needs to be different. Here what's happened, not only sitting, this person has to pedal also. For this pedal what's happened, the thigh movement space in these two area, it has been given a specific feature. So, that it allows one person to move his legs and that is the thigh area. So, this type of interaction is there. So, the interface between this object and the person's inner thigh movement has to be established properly. So, and then the angle of the seats and etcetera has to be considered. So, that with bending forward with using the body weight and it also helps in pedaling. Now, another thing is that with that same cycle, when a person carries something, normally we carry with a basket at the front cycle here or at the rear end at the carrier. Now, need is varied. So, if we keep our eyes and ears open in our surroundings, lot of need we can find out that can be addressed with design attempts. Here, he is a person, he is in faculty of Kanpur IIT. In this case, he has developed a special arrangement for his own son, that his son wishes to go out with the cycle with his father. So, what he has done? He cut this two area here and put a special wooden board, so that the boy can sit here with the legs out, and this platform can be used as a special footrest, and then it can be cycled. So, no problem. So, now this is a person's own innovation. Now, whether this type of innovative ideas has real design application, that one need to consider. Here what's happening? The person also moves, he is carrying someone, then a special context is required, and then here a lot of consideration of safety, and then his body dimensions and etc. all are there. Now, we can say that both moves in same direction, that we said, and cross over any one station, and both moves with varied direction and speed, person and the object. So, with that we can see this airport horizontal conveyor belt. Horizontal conveyor belt system is that it reduces someone's walking load. Now, if we see here in this small filmlet, then we can feel that how it operates. In this case, we can see that the conveyor belts moves forward, persons are also walking on this. Now, the walking speed of this person in respect of time and space is a faster with this. Someone may not walk even on this, but it is seen that not only walking, person also carry some luggage with them in hand. So, now whether this space in between is enough, or we need to do something else here also, means that we need to consider. Now, specifically it can be said that now we are coming to the point human vertical movement. Now, this airport conveyor belt is it horizontal movement and bending and etc. But now, the vertical movement is that a person can move vertically up, diagonally, or in a spiral movement. So, what would be the considerations? Like that, the steps and stairs and elevator and spiral. Now, here if we would like to see that the steps here, it is not only the young person's steps, but where the old person's moves, whether it is a forward movement, when you are climbing you can hold some railings, you can get support, but while coming down with the total body weight there is a problem. So, you require a good support, so that there should not be any toppling sense, falling down sense. At home and etc., we know everything, that what is the step height. Normally, we say that if a person's from the lower leg height, that lower leg height is 1/3 roughly, it can be the stair height, steps height, so that it will be very less tiring on the thighs muscles. Now, we know it, at home what is this, but when we do not know in some public building or some cases we have seen now in some unknown places, then this should be considered and the special lighting and etcetera it should be there, otherwise it will be problematic. Now, another case is that for the movement, when we normally walk, how much our foot comes up from the floor. It is seen that when we normally walk, around 4 to 5 centimeter only our legs come up from the floor. Now, if on a floor, if somewhere or something has to be laid and that we need to see that, means it should not be buried under the floor, it needs to be visible, then what would be the height of that? So, if it is below 5 centimeter, then it would not hit foot, you can walk over that without notice of any tension on your thigh muscles like that. So, these are the some considerations we need to take. Now, another aspect is that lifting our own body weight with load. So, whatever considerations we said without load, but now if load is there, then a total requirement will change, varieties of load, like in this case. Now, the person's lady and person while climbing on it, so there is no staircase and not even that, and while working, then what would be the considerations for this? These things are also required. For design, we are not only designing the office area or any multi-storied building, but such cases we need to consider that the day-to-day aspects of our life. This is another area, that space or the garden watchers tent area, the going up, working, sitting like this, that space need to consider. Now, movement and safety. For movement and safety, how the design can work. Now, she is pulling this. Now, only if they pull it, at home everybody we have the problem, either we roll this cylinder or we use a special stand kind of thing. Now, for the stand is like this with the swiveling wheels 4, so we put on it and then pull it. This is fine, but now the see that while putting on it, a lot of problem is there, and to bring it down is also same problem. So, in that case, the simple solution, there are a lot of solutions people have developed for carrying like this. So, what happens if it is like this, this handle and etcetera, then the cylinder you can bring it here and then push it like this. So, what happens, the cylinder will face like this and then you can move it, and then while pulling it, while unloading this, make it up. So, it will automatically come this side and then it will stand like this way, like this. So, this type of development possibilities are there. Now, so for this type of development, we need to specifically look into how people work, how people demand, what people demand. Accordingly, give design thoughts. In this case, the person is guiding this, whereas in this case, he himself is adding load, the force to this. Then this yoke and etcetera, it is made for the cows, bullocks, but not for the person. So, if this type of activities is necessary, then either what type of design thinking we should have, that we needs to be considered. And so, means what I would like to say that we need to see what is happening in our surroundings, the movement, force requirement and the task requirement, and accordingly give some design solution where man is the prime system component. As per his benefit or as per his convenience, do the design. In this case, in a railway platform, a very long wire, metal wire has to be shifted from one place to another place. Now, see the people are holding and pulling it. Can any design be given here either for method improvement, method of carrying this improvement or some other things? Now, when we say the safety and the movement and the work surface. Now, in this airport, this person is cleaning the glass with different things, and so the special tying things provided here, so that he should not fall. Now, here which one is necessary to maintain this slope? If it is there, then how it will be cleaned and like this? So, means then we have to decide which one is priority, what is actually required, and then keeping that fixed, other alternative we have to think. The person inside here, lot of movement possibility are there, lot of movements are necessary to come out, to go in, to operate the machines. The passengers going in and coming out, passengers age, their range of movement, whether they will be able to go inside or not. So, then in that case, if he has to move like this, come out and go in, then whether there will be a fixed seat or the seat may be movable, all sorts of concerns are coming in mind. So, basically we need to know that what is our normal body movement ranges. Now, we would like to see this body movement range and joint angle normal. In this case, if a person stand, this head, body, hip, foot, leg. Now, head can go right side and left side around 40 degrees, 40 degrees. At back means at around lumbar region, the body can bend 40 degree right, 40 degree left like that way. At hip area, the thigh full leg can outer side means lateral side can go till 45 degree angle and inner side around 40 degree angle. At knee, inner side it can bend around 50 degree, external lateral side around 20 degree. Here the foot at the lateral side it may go till 90 degree and here around 45 degree and 15 degree and 10 degree at fixed shank and 45 degree and 90 degree with shank rotation. Now, if here the main trunk bends at 40 degree and then head can bend another 40 degree. So, then total movement with a body bent and head bent it may be around 80 degree from the central axis. Like this it has to be considered in our design, how we can move and etc. Now, from the side plane, this was the frontal, this is the side profile. Now, side also you can say that head can bend front around 45 degree and back around 30 degree. At lumbar region frontal 40 degree and back around 10 degree lumbar extension. At hip the body can go around 70 degree and 20 degree hip extension. Now, here leg, the thigh, the full leg can go back around 45 degree leg at hip back position and frontal it may go till 70% degree and here around 90 degree angle at the hip leg front the knee flexion sitting at 90° angle, and assist raise it may come below this around 80° angle. Squatting it comes around 25° angle. Here frontal upward 40°, lower 45° down it can go. Now, the total body movement, the whole body at the arm, the inner side movement is called abduction, around 45° it can come, and then maximum it can go around 180°. Head rotation left and right both at 55°, head right and left like this way, it can go around 55° one side. The total body movement like this way, it has 35° on this. Now, the arm at this movement from at an elbow around 55° and below around 90°. This means around 55° it can go like this way maximum. And here the arm movement in a circular way, that vertical upward and vertical downward, and at this flexion arm flexion 90° and backward arm upper arm around 45° angle. So, hyper extension to back, and this is the vertical upward movement. And here what above the head like this way, whole 360° it can move, and from this like this way total sideways 360° movement is there possible. But all these are for a normal body, common able bodied, but there are physically challenging features, and adults they can, and for the old people, for them it has to be considered, it is a restricted movement. Now, how much restricted it needs to, it varies, and accordingly design has to be done. Like this palm movement like this way, this side is that radial side is at 30°, and lateral side ulnar side is a 30° and 40°. Palm up and down it is at 65° extension, top and bottom 80°. This fist movement like this way in a fixed area, this is that pronation is 90° and supination is also 90° like this way. So, these are the normal body movement ranges. Now, whatever movement we do and the design of the body supported device or any work equipment we design, so this has to be considered. Now, its design application specifically we will see later, we will discuss this. Now, with this we are concluding today's session of movement, human body movement and performance relevance. So, next session the class number 22, that this will be the work counter. Work counter means for normal activities, height, length, breadth of a special work area, where either horizontal or vertical or slant or any combination of this work area are necessary, and what would be their considerations. So, next we will discuss the work counter. So, till then goodbye and see you next.